Often, with the appropriate power tool, you can quickly perform a task that would otherwise be beyond your strength or would take an unreasonable amount of time. However, to use any power tool safely, you must be familiar with the tool, how it operates, its purpose, and its limitations. Simply put, a power tool is any tool that's driven by some means other than manually. There are many different types of power tools. One way to classify them is by their power source. In these terms, power tools may be electric, pneumatic, hydraulic, or explosive. Electric power tools must be connected to a source of electricity before they can be operated. Pneumatic power tools use a compressed gas, usually air, as their power source. Hydraulic power tools are powered by fluid or hydraulic pressure that's usually produced by hand pumps or electric pumps. And finally, explosive or powder-actuated tools use the energy from a gunpowder charge to drive fasteners into material. To operate explosive tools safely, you must have special training that is not covered in this unit. Another common way to classify power tools is by their function. For example, power tools may be used to drill, saw, grind, hammer, or perform many other functions. Often, both the power source and the function are used to describe a specific power tool. An electric drill, for instance, is a power tool that's driven by electricity and used for drilling. Power drills are commonly used for making holes in wood, metal, plastic, and other materials. Sometimes, with certain attachments and accessories, a power drill can also be used as a sander, polisher, grinder, or saw. The drill bit, when driven by the drill's electric motor, rotates with the chuck and does the actual drilling. In most electric drills, the chuck has one or more chuck keyholes. A matching chuck key is inserted into the holes and used to secure or release the chuck's grip on the drill bit. Some power drills have a keyless chuck. The chuck on this type of drill is turned by hand to tighten or loosen the hold on the drill bit. Many power drills also have variable speed controls to regulate the rotational speed. As a rule, drilling a relatively heavy material, such as thick metal, requires a slower speed with greater torque or turning power than is needed for drilling a lighter material, such as wood. This is a cordless electric drill. It's powered by a rechargeable battery pack. The pack is detachable and can be plugged into a battery charger. Because of the weight of the battery pack, a cordless drill is generally heavier than a similar size corded drill. Also, a cordless drill is usually less powerful than a similar size corded drill. Cordless drills are most often used when work must be done in areas where a power cord could get in the way, or in areas with no convenient power source. Another type of power drill is a hammer drill, so named because of its hammering or pounding action. It's used for drilling into concrete, brick, or tile. Because its drill bit rotates and hammers at the same time, a hammer drill works much faster than other types of portable power drills. Hammer drills typically use masonry bits or percussion bits, because only these types of drill bits can withstand the high impact involved in the operation of this type of drill. A pneumatic drill is a power drill that's driven by compressed air and is sometimes referred to as an air hammer. Pneumatic drills are most often used when there's no electric power source in a work area or when non-sparking tools are required. One other type of portable power drill is an electromagnetic drill. It's a portable electric drill that's mounted on an electromagnetic base and used for drilling relatively thick metal. When the magnetic base is placed on a metal and energized, it holds the drill in place for operation. A power saw can make quick work of what would be a tiring job with a handsaw. But for safety and efficiency, you must use the right type of power saw for the job, and the blade must be compatible with the material that's being cut. Here's one type of power saw, a circular saw. With the appropriate blade, it can be used for cutting wood, wallboard, plastic, fiberglass, metal, and other materials. The circular saw's name refers to the shape of the saw's blade. Several other names are also used for a circular saw. It's sometimes referred to as a skill saw because the Skill Company manufactured the first portable circular saw. It may also be called a cut-off saw, a utility saw, or a builder's saw. The blade and how it operates are important features that distinguish one type of power saw from another. A circular saw has a circular blade with teeth that are designed to cut on the upstroke as the blade rotates. The diameter of the blade indicates the size of a circular saw. Blade speed is given in revolutions per minute, or RPM, when the blade is running freely, not cutting through material. The retractable lower blade guard pivots back into the blade housing while the saw is cutting. Then the guard automatically returns to its original position to sheath the blade after the cut has been completed. Never use a circular saw without its lower blade guard, or if the guard's spring-loaded retracting mechanism is damaged or fails to operate properly. The blade of a power jigsaw cuts with an up and down stroke. The saw has a plunger with a collar that the blade fits into. The saw's shoe plate or foot plate provides a broad surface that helps keep the blade aligned during cutting. The shoe plate also helps keep the work from vibrating and helps the teeth of the blade bite into the material. The shoe plate also tilts, which enables the power jigsaw to do bevel cutting. Bevel cutting is simply cutting at an angle other than a right angle. It produces a sloped cut. Interchangeable blades enable a power jigsaw to cut a wide variety of materials, such as wood, certain metals, plastics, wallboards, and ceramic tiles. Power jigsaws can make both straight cuts and curved cuts. They're normally used with short, thin blades to cut curves and openings in boards or panels, or to cut out intricate patterns or irregular shapes. They're excellent tools for cutting circles. This is a reciprocating saw. It has a straight, flat blade that cuts horizontally with a reciprocating or back and forth motion. The blade is made of specially hardened metal to improve its cutting ability. However, the hardening of the metal also makes the blade relatively brittle, and a damaged blade can easily break or shatter. A reciprocating saw's shoe plate may swivel, or it may be fixed. Either way, it provides a brace point for the tool during sawing. Reciprocating saws may be used to cut irregular shapes and holes in plasterboard, plywood, studs, metal, and many other materials. Because reciprocating saws can be used at various angles, they're often used for sawing through walls or ceilings, and for creating openings for windows and plumbing lines. This is a portable handheld bandsaw. Portable bandsaws are versatile tools. They can cut pipe, metal, plastics, wood, and irregularly shaped materials. They're an especially good tool for cutting thick metal. When heavy grinding needs to be done, a power grinder is an obvious tool for the job. But power grinders are not limited to grinding. With the appropriate attachments, a power grinder can also be used for many other jobs, such as cutting, buffing, and drilling. One common type of power grinder is an angle grinder. It's a relatively large and powerful type of portable grinder that's typically used for quickly grinding away large amounts of hard, heavy materials, such as metal. An angle grinder, also called a side grinder, has a grinding disc or other attachment mounted at a right angle to the shaft of the tool's motor. The maximum RPM, or revolutions per minute, that a grinding wheel can withstand are marked on the wheel. Before using a wheel and a grinder, you should make sure that the maximum RPM for the wheel is greater than the RPM rating on the grinder's nameplate. If the rated speed of the grinder exceeds the rated speed of the wheel, the stress from the excessive rotational speed of the grinder could cause the wheel to break and fly apart. Another type of portable grinder is an end grinder, so named because the wheel or other attachment is positioned at one end of the tool. The rotating shaft of the grinder runs parallel to the axis of the casing. An end grinder may also be referred to as a horizontal grinder or a pencil grinder. The variety of attachments available for use with an end grinder directly contributes to the versatility of the tool. Although the attachments are usually called wheels, they come in a virtually endless assortment of abrasive discs, cones, bits, blades, and wire brushes. An end grinder is smaller and less powerful than an angle grinder, but because of its relatively small size and correspondingly small attachments, an end grinder is a useful tool in tight places, such as inside pipes. Also, because its shaft runs parallel with its casing, an end grinder provides the tool operator good visibility of the work and good control of the tool. A bench grinder is a stationary power grinder. The grinder is usually mounted onto a workbench or a stable freestanding pedestal. Bench grinders are often used to sharpen cutting implements and to smooth cold chisel heads that have become ragged and worn or mushroomed. Attachments such as knot wire brushes and cloth buffing wheels can be used in place of grinding discs to enable a bench grinder to perform other jobs. In this part, we'll look at jackhammers and hydraulic jacks. We'll start with the jackhammer. It may also be called a paving hammer, a pavement breaker, or an air drill. A jackhammer is a heavy-duty pneumatic tool that's used for large-scale demolition work, such as tearing down brick or concrete walls and breaking up pavement. Most jackhammers have a T-shaped handle that provides a two-handed grip for the tool operator. The handle also has a throttle on it. When the throttle is held down, it allows compressed air to be delivered to the tool through the air hose that's attached to the jackhammer's air inlet. The compressed air operates a piston that's inside the jackhammer's casing. The up and down movement of the piston drives a steel cutting shank or other attachment at the end of the tool, so that the attachment pounds into the material to be broken. Jackhammers may have different attachments, such as chisels and spades, that enable the tool to be adapted for use in a variety of situations. A useful power tool for heavy lifting is a portable hydraulic jack. It's sometimes called a porta-power, which actually is a manufacturer's name for a specific model of hydraulic jack. Depending on the attachment that's used with the tool, a portable hydraulic jack can be used for lifting loads, pushing heavy objects, pulling wheels, bearings, gears, and cylinder lines, and for straightening or bending frames. In some cases, a hydraulic jack's pump is driven by an electric motor or a gasoline engine instead of a hand lever. Another common type of hydraulic jack has an internal pump, so no hose to the cylinder is needed. Other than that, the parts and operation of this type of jack are essentially the same as those for a jack that has an external pump. A moment's carelessness when you're using a power tool can swiftly lead to serious consequences, so it pays to follow some common sense precautions to ensure your safety on the job. First, take the necessary steps for your personal safety. Eye, hearing, and respiratory protection are common requirements with many power tools. But you must use whatever personal protective equipment is needed, based on the hazard assessment that was done for the job. You should also dress appropriately. Keep shirt cuffs buttoned, shirt tails tucked in, and long hair secured out of the way. And don't wear rings, watches, necklaces, or dangling jewelry that can get caught in the moving parts of power tools. Other safety precautions are associated with the work site. Never use a power tool anywhere that the heat, sparks, or debris generated by the tool can set off a fire or an explosion. Before starting work, make sure that no other people in the area could be injured by either the tool or the sparks or debris that using the tool might generate. When you begin a job, secure the work material to a work table, bench, or other surface with a vise or clamps. This prevents the power tool from throwing the material off the work table and causing serious damage or injuries. If the work material is overhead, you should stand on a scaffolding or other stable platform that enables you to reach the work comfortably. Don't stretch upward with the power tool to do the work. Likewise, never hold a power tool in such a way that it could fall on or against you if you happen to lose your grip. Another key safety factor is your familiarity with the tool. Read the instruction manual before you operate the tool. You must know how the tool works, how it's controlled, its limitations and capacities, and any special safety precautions that you should follow. Make sure the power switch is in the off position before you connect the tool with its power source. After making the connection, test the functions of the tool's controls. You must be able to switch off power to the tool quickly if an accident or an emergency occurs. When you're using a power tool, stay alert and keep your mind on what you're doing. Most power tool accidents occur when the operator's attention wanders. Keep all parts of your body a safe distance from the working end of the power tool. Generally, if you notice abnormal vibration or noise from a power tool, you should turn the tool off immediately. Then report the problem so that it can be corrected. Never walk away and leave an unattended power tool running or even connected to its power source. Before leaving, turn the tool off. Then follow the appropriate procedures to disconnect the tool from its power source. Finally, clean and store the tool properly and follow the manufacturer's maintenance recommendations to keep the tool in good working order. A number of safety precautions that are associated with the flow of electric current must be followed when you're using electric power tools. For instance, every electric power tool must be either grounded or double insulated. A grounded tool typically has a metal casing, and its power cord always has a three-pronged grounded plug. The third prong on the plug is called a ground pin. It's designed to fit into a matching hole in a grounded outlet, which puts the ground pin in direct contact with a conductor that leads to ground. This double-insulated tool's power cord has only a two-pronged plug, but the tool's casing is made of a plastic insulating material. The tool also has insulation that isolates all the internal metal parts of the tool from contact with the operator's body and protects the operator from electric shock. In short, both grounded tools and double-insulated tools help protect tool operators from the hazards that are associated with short circuits and ground faults. But a grounded tool is not safe to use unless the conductors and insulation in the power cord are in good condition, and the ground pin is firmly seated in the plug. Likewise, double-insulated tools only provide adequate protection if they're in good condition. So handle these tools carefully. Their plastic casings can easily be damaged, and a crack or a chip in the casing could give electric current a path through which it could enter your body. If you have to use an extension cord with an electric tool, make sure that the extension cord meets safety standards and is used correctly. Also, whenever you're using an electric tool, stop using it if you experience even the slightest electric shock, or if you think the tool isn't operating properly. When you finish a job, turn the tool off and wait for its moving parts to come to a complete stop. Next, if you're using an extension cord, unplug it from the outlet first to avoid creating a shock hazard with the free end of the cord. Then disconnect the extension cord from the power cord. Finally, always carry electric tools by their handles, never by their power cords. Cordless, battery-operated electric tools have some additional safety concerns. When you're using a cordless tool and you must stop work for a while, lock the tool's power switch in the off position. If possible, also remove the battery pack. Together, these actions will prevent accidental startup of the tool. You must also follow the necessary safety precautions when you recharge battery packs. And be sure to use a charger that's designed for the specific battery pack or tool that needs recharging. The use of pressurized air to operate pneumatic tools carries with it a number of special safety concerns and procedures. First, before connecting a pneumatic tool to a compressed air source, make sure that the air pressure of the source doesn't exceed the maximum rated pressure that's listed on the tool's nameplate. Also, before using a pneumatic tool, make a thorough inspection of the tool and its attachments, connectors, and air hose. To be sure that you safely connect a pneumatic tool to its compressed air source, follow an orderly step-by-step procedure. In this example, you must first connect a plant air hose to an outlet of the plant service air system, while the outlet valve for the air source remains closed. Next, test the plant air hose by shooting a blast of air through it to determine if there are any obstructions, dirt, or water inside. Be sure to wear safety goggles to protect your eyes and point the hose in a safe direction, away from yourself and other people. After the plant air hose has been tested, you must close the air source outlet valve. Then, connect the free end of the plant air hose to the connector on the outlet end of the pneumatic tool's air hose. Make sure the connectors fit together properly and that the connection is secure. To help prevent injuries and damage that could be caused if the plant air hose breaks or becomes disconnected while the tool is in use, attach a safety wire at the connection. The loop on one end of the safety wire is secured to the end of the plant air hose. The loop on the other end of the safety wire is attached to the connector on the outlet end of the tool's air hose. With the safety wire attached in this way, the plant air hose is prevented from whipping around out of control if it becomes damaged or disconnected while under pressure. For the same reason, a safety wire was also attached on the connection between the plant air hose and the air source outlet. With the tool securely connected to the air source, you should now open the outlet valve at the air source and make an operational test of the tool before proceeding to put it into use. Never leave a pressurized pneumatic tool unattended. When you finish a job, or if you must walk away from the tool for some reason, turn off the tool and close the valve at the air source outlet. Turn the tool on and wait for it to run out of air and stop. This action drains or bleeds any remaining air from the air hoses and the tool so that the tool can't start up accidentally. In this example, if you're ready to put the tool back in storage after you've bled it free of air, you should first disconnect the plant air hose from the compressed air source. Then, disconnect the other end of the plant air hose from the connector on the outlet of the tool's air hose. And finally, disconnect the tool's air hose from the tool's air inlet. In this part, we'll look at how to use and care for portable power drills once the general safety preparations for using the tools have been made. We'll use an electric drill as our example because most of the rules for the operation of this type of drill also apply to other types of power drills. Before you use an electric drill, double-check to be sure that the tool is properly protected against ground faults. Also, make certain that you have the right drill bit for the job before you load the bit into the chuck. To load the bit into the chuck, first make sure that the drill is disconnected from the power source. Then, open the chuck and insert the shank of the drill bit as far as it will go. Now, turn the chuck's collar to close the chuck's jaws around the bit. Be sure to keep the bit centered in the chuck as you tighten the collar. Next, use the chuck key to tighten the chuck and secure the bit. Don't forget to remove the key from the chuck before you begin drilling. To keep from losing the chuck key, attach it to the power cord. When you prepare the material that you'll be drilling, Make a small indentation to mark precisely where the hole is to be drilled. Make sure the drill's trigger is in the off position, then connect the drill to the power source. Start the drill motor and make sure that the drill bit is rotating in the proper direction. With the bit facing away from you, it should be turning clockwise. Next, turn the drill off and position it so it's perpendicular to the surface of the material at the indentation that you made earlier. Now turn the drill back on and allow the motor to rev up to operating speed. Then you can begin drilling. Hold the drill with both hands and apply a steady, moderate pressure, letting the drill do most of the work. Forcing the drill with too much pressure is likely to dull or break the drill bit. Never ram or shove the drill while you're drilling. This can chip the drill bit's cutting edge and damage the motor's bearings. Maintain an appropriate speed by adjusting how hard you pull on the trigger, not by using the locking button. Throughout the drilling procedure, keep the drill bit positioned at the angle that's correct for the job. Changing the angle of attack can break the drill bit. If you're drilling a relatively deep hole with an electric drill, you should pull the drill bit partially out of the hole periodically to clear shavings and excess material out of the hole. If the drill bit gets stuck in the material while you're drilling, turn the drill off. Change the bit's direction of rotation with the reversing switch, then turn the drill on again and back the drill bit out of the material. When you've finished backing out, turn off the drill and reset the bit's direction of rotation with the reversing switch. Then resume drilling forward into the material. When the drill bit is about to emerge from the opposite side of the work, reduce the pressure that you apply to the drill. If you don't ease up on the pressure, the drill could jerk out of your hands when it completes the hole. When you're drilling metal, lubricate the bit to cool its cutting edges and to help produce a smoother finished hole. Generally, a light machine oil makes a good lubricant for drilling relatively soft metals. No lubricant is required, however, for drilling wood. Most electric drills require very little maintenance. Many have gears and bearings that are lubed for life. However, it's a good practice to remove dirt and debris from the drill's air vents with a small brush when the tool is disconnected from the power source. Also, after use, drill bits should be cleaned, lightly oiled, and then stored properly, preferably in the case supplied by the manufacturer. There are a number of basic procedures that apply to the use and care of almost all portable power saws. For example, when you're inspecting a power saw, it's important to make certain that the blade is securely in place. It's also important to properly secure the material that you'll be cutting. Make a cut mark or layout line on the material to indicate the line to be cut. Set the saw to the correct speed for the material. Start the saw and allow it to rev up to full speed. Then move the saw forward to start cutting. Don't force or push the blade. Let the saw do the work. As much as possible, keep both hands on the saw while you're operating it. Also, stay aware of where the power cord is so that you don't cut through it by accident. When you've finished cutting, release the saw's trigger and allow the blade to stop running before you lift the blade from the work. Finally, follow the specific recommendations in the saw's operating manual to keep the tool in good condition. During the pre-use inspection, make sure that the retractable lower blade guard is functioning properly before you connect the circular saw to the power source. When you're preparing the work material, make the cut mark on the waste side and secure the work so that you'll cut with the good unmarked side of the material facing down. You see, when a circular saw's blade rotates, the teeth come from the lower side of the work and cut up into the material, producing a kerf or channel. If you cut with the waste side up, any splintering that occurs will be on the waste side of the work. Next, set the saw's depth of cut to the desired value. Place the front edge of the saw's base plate on the work so that the notch in the saw's guide slot is in line with the cut mark that you made. To begin cutting, grip the saw with both hands and stand to one side of the work so that you won't be hit by the saw if it kicks back during operation. When you begin cutting, remember not to force the blade through the material. That could cause the saw to bind, jam, or overheat. The blade could be damaged, and you could be injured. As you approach the end of a cut, the guide notch area of the base plate will be off the work, so use the blade as your guide to complete the cut. One critical part of circular saw maintenance is cleaning the lower blade guard. Sawdust or other debris can accumulate in the retracting mechanism and cause the guard to stick. To clean the lower blade guard, remove the blade from the saw after the tool has been disconnected from the power source. Then clean the interior of the guard with alcohol or mineral spirits. This helps keep the guard from rubbing or binding and ensures that the guard will shut quickly and smoothly. Don't, however, lubricate the guard with oil or grease. When the saw is in use, accumulating sawdust or other debris can be held by the lubricant, causing the guard's retracting mechanism to stick. Next, let's look at some operation and maintenance concerns that are unique to power jigsaws. During the pre-use inspection of a power jigsaw, make sure that the blade is inserted as far as it will go into the collar of the plunger and is securely held in place. The work material should be positioned with the good side down, and the cut mark should be made on the waste side of the material. To position the saw for cutting, align the front of its base plate or shoe plate with the cut mark. Then make sure that the front of the saw's shoe plate is resting firmly on the surface of the work. Once the saw has revved up to operating speed, move the blade gently into the work. Pushing the blade into the work is one of the most common ways in which power jigsaw blades get broken. Also, forcing or leaning into the blade could result in your pitching forward or your hands going into the work surface and getting cut by the blade. When you finish a cut, let the blade come to a stop before removing it from the work. This prevents marring the work and possibly breaking the blade. Replacing a broken blade is a common power jigsaw maintenance task. Always unplug the saw first and wear safety gloves to protect yourself from getting cut. Before inserting the new blade, make sure that there are no broken off pieces of the old blade lodged inside the collar of the plunger. Then insert the new blade as far as it will go into the collar and secure the blade in place. You should grip a reciprocating saw with one hand on the handle and the other hand on the body of the saw to keep it stable during cutting. Place the shoe plate firmly against the piece of work. Then squeeze the trigger to turn on the saw. The blade then moves back and forth, cutting on the backstroke. The operation of a portable bandsaw involves some concerns that apply specifically to this type of power saw. For one thing, you must place the stop that's below the band firmly against the object to be cut. This will help keep the saw from bouncing against the object and breaking the band during operation. Portable bandsaws generally cut best at relatively low speeds. Higher speeds can cause the band's teeth to rub against the work instead of cutting it. The rubbing action generates excessive heat and can cause the saw's blade to wear out quickly. Only the slightest pressure is needed to make a good clean cut, since the weight of the saw itself helps produce adequate leverage for cutting. However, a portable bandsaw's blade can bind or stick very easily, so never force the blade. In this part, we'll look at how to use and care for several different types of power grinders once the standard safety preparations have been made. To begin with, let's look at some procedures that apply to the use and care of virtually any power grinder. Always use a spark deflector or a face shield, as well as proper eye protection when you're doing grinding. Before you use the grinder, make sure the wheel and its guard are securely in place. Also, make sure there's sufficient clearance between the guard and the wheel so the wheel can rotate freely. Another important preparation is selecting the proper attachment or wheel for the type of work that's involved. The rotational speed of the grinder must not exceed the rated speed of the wheel. If the wheel is damaged, or as in this case, its edge has been worn down to the identification label, the wheel must be replaced with a new one, according to standard procedures for the grinder. Because you can easily be pulled off balance when you're operating a power grinder, make sure you have a solid footing and a firm grasp on the tool. During the operation of a handheld grinder, the amount of downward pressure that you should apply to the grinder depends on the type of work that's being done and the type of grinding wheel that's being used. For instance, using a wire brush wheel to remove materials such as dirt or corrosion requires only enough pressure to keep the surface of the wheel against the work. Also, always direct any sparks and debris generated by grinding away from personnel and any materials or equipment that could be ignited, contaminated, or damaged by sparks or debris. Finally, when you stop using a grinder, shut off the power to the grinder and remain with the tool until the grinding wheel has come to a complete stop. Now let's look at some concerns that apply specifically to angle, end, and bench grinders. When you're using an angle grinder, hold the tool with a two-handed grip. Place one hand on the handle of the grinder and the other hand under the tool's casing to support the motor. An angle grinder is a heavy-duty tool, and you generally need to apply a fair amount of downward pressure on it during heavy grinding. Keep in mind, however, that the greater the pressure applied on the grinder, the greater the friction between the grinding wheel and the material that's being ground. In turn, there's greater strain on the grinder's motor and an increased possibility that the grinding wheel could break. End grinders are smaller than angle grinders, but they still require a two-handed grip for maximum control of the tool. Hold an end grinder with one hand at the shaft end of the tool and the palm of the other hand supporting the motor end of the grinder. And always keep your hands a safe distance from the grinding wheel when the tool is operating. A bench grinder is generally mounted onto a bench or a pedestal, so you don't need to hold on to the grinder to control it during operation. But before you start the grinder, you do need to adjust each of the tool rests so that they're about 1/8 of an inch from the wheel. This reduces the chance of the works getting wedged between the tool rest and the grinding wheel. When you're ready to start the grinder, stand to one side rather than directly behind the tool. This helps keep you from being in harm's way if the wheel has been damaged and flies apart when you start the grinder. Let the grinder come up to full speed before you apply the work. Whenever possible, use the face of the grinding wheel. But sometimes the nature of the work may require you to use the edge or side of the wheel, so inspect the wheel frequently to be sure that you don't reduce the wheel's thickness to the point where it's no longer safe to use. In this part, we'll look at how to operate and maintain jackhammers and hydraulic jacks. We'll begin with a typical jackhammer. Before you connect the tool to its power source, you must make the standard safety preparations. If you're using a jackhammer to break up pavement or do similar work, always find out what's below the material before you start breaking it up. Serious damage and accidents can result if you hit underground utility lines. You also need to make sure that you have the appropriate personal protective equipment, such as hearing and eye protection, gloves, and the proper type of safety boots. A jackhammer is, of course, a pneumatic tool, so standard procedures must be followed to connect the tool with the air source safely and securely. Next, make sure you have a good two-handed grip on the jackhammer's handle and a stable footing so that the action of the tool won't throw you off balance. You'll need to follow the operating procedures for the specific jackhammer that you're using, but there are a few operating guidelines that apply to most jackhammers. Stand erect as you operate the jackhammer and let the tool do the work. Let the weight of the tool rest against the material that's being broken up. Don't rest the jackhammer against your body. The repeated jarring action of the jackhammer can cause stress injuries to the tool operator if the tool is used continuously for prolonged periods. So, for most jobs, you'll need to take breaks at regular intervals. The next tool that we'll look at is a hydraulic jack. During the pre-use inspection of a hydraulic jack, you should check the level of fluid in the hydraulic fluid reservoir and examine the jack for fluid leaks. If the jack has a separate pump with a hose that connects the pump to the hydraulic fluid reservoir, check the hose and its connections for leaks and damage, and make sure that the hose isn't twisted or kinked. If the jack uses a motor or an engine to drive the pump, test the control for the motor or the engine before you use the jack. In this case, we're using a hydraulic jack with an external pump and a hand lever to lift a load. First, place the jack cylinder on a hard, level surface beneath the load, with the center of the cylinder's piston under the load's jacking point. Next, initiate the lift by pumping the hand lever, which raises the jack cylinder. Don't use an extension or cheater bar on the pump's hand lever, and don't move the pump if the hose is under pressure. Also, watch for leaking hydraulic fluid during operation. To lower a load that's on a hydraulic jack, simply use the release valve's thumb screw to open the return passage to the hydraulic fluid reservoir. The weight of the piston and its load then pushes the fluid in the cylinder back into the reservoir. When you're done using a hydraulic jack, check the tool for damage, especially to the hydraulic fluid hose and its connectors. Then clean and store the jack properly, according to the manufacturer's recommendations.